If you're like me, you've done countless homework problems on factoring quadratics, and you've sat through tests where you wish there was an easier way. Well, it turns out there is, the quadratic formula. But to understand what it is and how to use it, we need to understand how we got it in the first place. First, let's start out with a regular old quadratic. Coefficients a, b, and c could be any old number, and we want to find x. So, how are we going to do it? Well, since we want x on one side and our answer on the other, let's move everything that isn't x to the other side, starting with c. We also want x by itself, so we need to pull out that a out of x squared. So we'll just divide both sides by a. Alright, now what? Well, we want x by itself, so maybe we can try pulling out an x? No, that doesn't work. Now we just have x times x. So now what? Well, we experiment. What can we do to get x by itself? I have an idea. This. Z is any old number, but why are we adding it to x and then squaring everything? Well, I don't really know. But let's find out. If we take the square root of the whole thing, we're left with, x plus z. Then we just have to get rid of z, and we have x by itself. So all we need to do is make our original equation into x plus z squared, and then we can get x by itself. But how are we going to do that? Well, we can expand out x plus z squared to get x squared plus 2xz plus z squared. And since we want to make our original equation into a square, we know that we'll need to add a z squared to it. But we already have our x squared and our 2xz. That means we can just find z. Turns out it's b over 2a. Now we'll take it and square it and add it to both sides of our equation. We'll make the denominators on the right-hand side equal to put it all together, and then we'll turn our big long thing on the left into x plus z squared. Now we'll take the square root of everything. On the left, that cancels out the square, so we're left with x plus z, but on the right, it's a little trickier. The denominator is a square, so the square root goes away, but the numerator isn't so lucky. And if that wasn't enough, we have this funky symbol next to it. What is it, an upside-down stick figure of a man with a flat head? No, it's a plus or minus symbol, meaning that the right side could be positive or negative. Well, how does that work? Well, let's go back into the world of regular numbers. We know 4 times 4 is 16, but negative 4 times negative 4 is also 16, and since the negatives cancel out. We take the square root of both sides of these equations. The square root of 16 could be 4 or negative 4, or plus or minus 4. This works for all square roots. Both the positive and the negative version of the answer are valid. But we still haven't found x yet. Not to worry, we're almost there. We can subtract z from x to finally get x by itself. Now we have x and all values of it. And this works for any quadratic, for any values. But an important reminder, don't just memorize the formula. First, it's pretty complicated, and I'm sure you'd rather put other information in your brain anyway. But second, you don't need to. If you know how we found this formula and understand the rules we use to get x by itself, then you can find x whenever you need to. Math doesn't have to be about memorization. All you have to do is know what the problem is, know what tools you have, and know how to use them.